Welcome back. In this episode, we will continue to explore the Innovate UK website that we have been using as an example in this series of web scraping with BeautifulSoup. I am going to start with the assignment I asked you to explore in the last episode, and that is to extract email contact of each investor partner that is listed in the Innovate UK website. Let's go to BeautifulSoup editor to start exploring, and I will show you my own implementation. Yours might be a better implementation, but let's look at this together to learn together. Like I used to say, if you find any information useful in this content that we provide, please endeavor to subscribe to our channel, videos, share with anyone that you think might benefit from this content. This will greatly encourage us and it will make us do more. So let's start from where we stopped. In the last episode, I said we have been able to extract this data from the Innovate UK webpage. We have been able to extract the investor description page link on the Innovate UK webpage. We are able to extract the investor's name, all the investors on that page, and also we extract the investors customized web page. So individual investors have their own web page where they document everything that they are involved in. So on the UK Innovate web page is just a description page that takes you to the past each a customized page of each of the investors. So this, if you're looking for something particular about each investor, you're going to look at the investor's web page. So those are the data we've been able to extract. So I said we should explore the site and extract data that gives us extract the email contact of a contact person within each of the investor partner companies. So I will realize that looking at this contact Alex Brown, if we click this one takes us to an email which we get the email from here. So one thing about this clickable link is that we already know that this is going to be an A tag within the HTML structure, and the A tag we have an href, which is the link that we get to if we click this clickable link. But the unique thing about this is that it takes us to an email. When I explored other investor partner that is listed here, I realized that it's not all of them that has this contact point that takes us to an email. Let me give you an example. I think the ADA, let's get to this ADA. So this particular one, if you click this place, it actually go to the ADA Ventures website, their website, not the email. So the difference between these two is that we have the value in the href within the A tag of the clickable link that takes you to an email, that's which we have here, which we click and we go to an email. This clickable link we have will start with a keyword mail to. So what we are looking for in this link, in this tag, the tag we are looking for to actually get those that has email within it will be a tag. An A tag, we already know that a clickable link is embedded within an A tag. We're looking for an A tag that has a href, and the href starts with mail to. We have the compiled list that we have done here. We have the compiled list here. Let me remind you, we have the compiled list here which has all this link that is enlisted in the UK Innovate website. So that link is the description page of each of the company enlisted on that website. So the compiled list, I will get the first link there, compiled list. I should have copied. Let me be sure I get the spelling. No, let me copy the compiled list. The compiled list is here, compiled list. So let's go back and use it. So we have this here, and so this leads to the first investor partner on the Innovate UK website. So let's get the BeautifulSoup structure to give us the HTML content and structure of this first investor partner on the list. So let's call this test soup, test soup is equal to this, so we want to extract this in here. And if we run this, it tells us that website successfully retrieved. So like I said, what we are looking for is a tag that is an A tag. So you know that this is a clickable link. Example is a clickable link, that means it's an A tag, and we're looking for the tag that has that href, and the href starts with mail to, and that's the difference between a link that goes to a website and a link that goes straight to the email, like the one we have in here. That's the difference. So let's look for an A tag first. We're looking for A tag. So from the test soup, we want to find an A tag. So we'll say .find, and we will find A tag, and the A tag we are looking for. So I want to use this lambda function. We have lambda href. So this will be the input to the function. This will be argument to the function, and the href that will be returned must start with mail to. Let's see if we have this within this structure. The first page, the Haymarket 24 Haymarket page. So when we run this, let us view the A tag. Let's view the A tag, and when you print this, you can see we get the A tag, and bravo, we have the contact Alex Brown here, and now the mail to is here. You can see the email, the Haymarket email. So how do we get this? Straight away we can just get the href of this A tag. We can say get href of this tag. Bravo, we have the email already, but we need the email. This mail to should be extracted from this text. So let's say we have mail text equals to this. Let's say we have mail text equals to this, and the mail text, now we want to say we want a split mail text. We take the mail text dot split by the character in between the mail and the email, actual email, and the mail to. So if I run this now, we will have a list. And if you look at this list, if we look at the first element of this list is going to have two elements that is splitted. So the first element will be the mail to, and the second element will be the actual email that we're looking for. So we can say our mail is equal to the split mail second element. So we can print our email now. So we've been able to extract the email successfully. So let's see if we change this to 1, and let's say we change this to 1, and we run this. If we change this also to 1, this will give us Act Ventures. So let's extract the structure of Act Ventures, and let's look for this href that starts with mail to. And if we look for that, let's get the href tag. And you see, you have the info at Act, that's email for Act Ventures, and we can extract it like we have done to remove the mail to. If we this and we click this, we have exactly what we need. So let's bring this together in a function that automates extracting that email for us for every of the investor partner description page. Let's say def get investor partners email, which will take an argument. This argument is let's say the argument here will be, okay, I want us to have something the same, consistent. So we have this here, and the first thing is to create the list, email list, which is this, and we want to iterate through this place. For link here, we will, for link in, so the in is 2, we will want to create the soup. Let me copy the function that do this extraction. So down back here, the function we have a temp soup. We call it temp soup is equal to this with the link in here. So when we get the temp soup, what did we do here? We look for the a tag that has href, and the href starts with mail to temp. Let's call it temp tag, and now this will be the temp soup, right? So then we get the a tag. We get the a tag that has the mail to. So we don't want to get into the problem that we had the other time. Let's assume some of the pages might not have this email on their page, so we will be sure that we have temp tag. So if we have temp tag, then we get the href from the temp tag. So we get href mail to text, mail to, let's call this mail to. So we get the href from this tag, and after that we will do the splitting to get the exact email. So let's split the mail to, right? And we know that after the splitting we have the email actually in the split text element, as in the second element of the split text. So when we get the email, then we append it to this place. Append email, and bravo, we will now say else means that if we didn't get this tag, that means the email might not be on that page, or the structure is different from what we have done. So this will append none to the email, so we'll be able to know which one doesn't have email, none. So this looks good. Then we will finally return the email list, and bravo, that's pretty much the automation of extracting the email from those link to the page description. So if we run this and we call this function to say email list now is equal to this function, then we put the compiled list, we should have it. What breaks now? Temp tab, not temp tag. It's not tab, it's tag. So let's run again. Wow, good. So let's wait for all the 117 pages to be extracted. Good. Up till now it's still good. So fine. Oh, I didn't do the numbering, so we couldn't get exactly when it ends, but it's finished now. So let's see the email list now. Let's view the email list. We call it email list, and we have the email list here. Let's print. This is pretty much good. Can you see the list of email to all of the investor? I think we get it all. None of them have none. So we have all this email as registered on the investor page. So some of these are not actually unique. You have emails that are almost the same, which is, let's say, inquiry. Here we have some of the email that is not unique to the investors. All this email now so are not unique to the investors, but at least we have extracted the email as it is on the UK Innovate page, so we can do further extraction later. Quickly before we round up, I mentioned that there is an error that can occur with the request, this web extract that we define here, this function that we define here. Let me demonstrate this error that we can get from here. Let's assume we have these two URL. The first one is an Amazon URL and link to Amazon, and the second one is a URL that is not a valid URL. So assuming we want to make a web request on these two URLs, let's see what happens. So if we have this, and first we want to make a web request on Amazon URL to return the soup structure for us. So test soup, let's say test soup, and we run this. Such response from HTTP request could signal many things. It could be due to high traffic volume, it could be due to maintenance rate limiting on that particular website. But primarily for Amazon, I think Amazon employs a measures to detect or block automated scraping or bot traffic on their website, so HTTP requests might not be successful. So you can see there is a 503 error from this. So we are able to catch this kind of error gracefully in our current function design. In the current design, we have this if statement that says if response status is equal to 200, you do this, and else. That means if response status is not equal to 200, that means in the case we have a response status that is 503, then you should the function should tell us what happened and return the soup. The soup is originally none, so it will return none. So in the case that we have non-valid URL, let's see what happens. Let's see what happens if we have this. If we ask that we want to get the substructure for this, let's see what happens. Can you see this will run into an error? And in a case that we want to run multiple URL like we have been doing for this, it will break this process and the error will not be caught gracefully. To avoid this, we should make some changes in our functions that extract the substructure from the web pages. Let's see the changes we make. I put this one up here. So get soup, initialize soup to none. Then the request. In making the request, we have to try. Let's use exception. We'll try the request, and in the try block, if the try is successful, the request response is gotten. This has been taken up. So we have try. In the try block, we check if we get the response from the HTTP request, and if we get the response, and we check again if the status is 200. If the status is 200, get the soup beautiful soup object structure, then tell us that this has been successful. So else if the status is not 200, then we have to print the fail message and tell us the status code. So this is all in the try block. So if the HTTP request is not successful and we have an error, then we go to the except block. The except block, and this will have we catch the exception as E. So this should be a tab forward indentation. So then we now have to print. Let's print the exception message, the error message. Let's print the error message. Error processing the HTTP request. So this error now on the URL, on the link. Let's say the link now is the URL, and we want to print the error message here and close the formatting. So then with this, we should be able to catch that kind of error without throwing the error and breaking our code. So if we run this now, you can see error processing the HTTP request, no scheme supplied. Perhaps you meant this. So you can see that we have we have been able to catch this error gracefully. And in case this is in a process like we have been doing with all this URL, it will not break this process. It will only return the soup none for us. Finally, before we end this episode, what we have been running to extract data since, you can see that each data set that we want to extract, when we want to extract the email, this runs. You see this website successfully retrieved 117 times. That is the number of investor description page that we have on the site. And the same thing when we want to extract the specific web page for each of the investors, and the same thing 117 times we see this when we want to extract the investor name. So we need to write this code more efficiently such that we won't repeat the same process like this in the multiple times. So how do we do this? So I have open another script which I call Combine, and here I will combine everything that we have done and write it in a more efficient way. So the first thing we did is to import the request and BeautifulSoup, and also the next thing we did was to write the code that extracts. I am copying it. So the code that extracts, we can see this, we know we've seen this before. This was the one we just created and we edited now. So if we finish, right, as in we have the code that extract the soup structure, and also we have the base URL. Let's copy the base URL from here. So we have the base URL. So the base URL is the UK Innovate website from where we're extracting the data. So after having the base URL, we also have this target class which helps us to get each of the investor description page. So this is the target class. Now we will we'll now write the description page link that turns the list from each page. This returns the list from each page. Let's look at this. Description page link returns the list from each page. You can remember how we did that. So after this description page link, this takes the soup and the target class. So then the next thing we did is to get the next page. You get the next page. So the next function gets the next page. So this one gets the next page from the base page. So after this function, we have next function that we have is get the investor link recursively. So we iterate through all the pages and we get to the investors. So we get the link to the investor description page. So let's look at what we have here. This takes in the URL, the page number, the target class, and the empty list that starts. So it returns all the link, all this link. This was the one that returned all this link for us, with which we are now iterating to extract the data from the investor description page. So now we want to write the combined program. So let's say def. So what name should we give the combined program? Now let's call it def get partner data from Innovate UK. So what we have here is URL, the page number. So now let's copy all that we have here, and we say now the link. We now say the link, the investor description link will be equals to this. The investor description link will be equals to this. So after we get all the link to the description page, the next thing we will want to do, I would create an empty. Before then, let me create an empty investor data. So this is going to be an empty dictionary. So when I create the investor link, the first thing I want to do, I want to also create this investor name list, which is also an empty list, investor mail list, which is going to be an empty list, then investor spec list, spec web, let's call it spec web list, which is also an empty list. So the first one gets all the link to this investor description page on the UK Innovate website. So now we will insert this into the dictionary. This is the dictionary that will contain all the data, and we call this key, let's call this one partner investor description page link. Let's call this investor description page link, and this will be equals to the link that we have gotten now. So this will be equals to the link that we have gotten now. Then the next thing is to have the investor email. The investor email, let's look for the function that creates the investor email for us. Where is that function here? Let's catch the investor name first. Let's look for this function, put it up here. So this function takes investor link, but I don't want it to take the investor link anymore. So I want to have to take the in soup. Let's call this in soup. So the in soup, so this numbering will not be here, this will not be here. So instead of returning, sorry, let me undo this. So this will be taken to the main, to the combine function. So it will only return one investor name. So the name is this, and we will have the name split as we have done, and this, then this will be out of it now. So it will return name for me. This is not here anymore, so we have only name returned. So that shortens that one. So now what we do here is this. We already have the investor description link here, so the for loop will be here, the investor description link. So the list of the investor description link. So let's put this one list so that we know that it returns a list. So we have this list iterated in a for loop. So we have the number here. We don't have name list anymore. We have numbering here, starting from here. So we also have investor name list here. So for this one, the first one, we will call this once. For the first investor description list, we will call the soup structure once. We get the temp soup. The temp soup is equal to, we have the web extract here, and the link will go in here. The link will go in here. So this will go before we extract that. So if the link go in here, then we will get the name, a name. So we will get a name, get temp name from the link, the temp soup, temp name from the temp soup. And what we do now is we append it to this investor name list. So instead of assigning it to this, let's just do the append straight to the investor name list. So we've got that. Then we need to get the investor email. Let's get the investor specific page now. Let's get that function here, pull it up. So we have the function up here. Instead of having the link, we will have in soup. So this is gone, this will be away. So for in soup, we don't need to extract here anymore. So we have target will be in soup. This will be in soup now. And if we have target, then this will get the ref for us. And we don't have to attach it to any, we don't have to append it now. Else, what's this? So else return none. And if this happens, let's say just return this for us. So it returns none or returns the investor specific link. So this is done, and we'll take this function down. We'll take this function down to say investor specific web list will be append. Sorry, we copied this function again. Let's copy this function again, and we append this here, and we have temp soup in here. So the next one is let me see. So the next one is to get the investor email list. Let's get the function that does that. Where is the function? This is the investor email list. So let's put it up here. and what's in this will be in soup again, and this will be off here. We need not this anymore. Then the in soup will go here. Sorry, the in soup will go here, and we say if tag. Then we look for this, right? We split it like this. Then we have email return. This list is gone, and we have this. So if this is not true, then we return none, and that is all here. So if we run this, so return this. Yeah, that's what I want to do there. So we can get email from the in soup. So let's have this, and we can append this to the email list. We append this to the email list, and that's going on gracefully. What else do I need to do here? So after doing this, we can now say in this for loop, we now say num plus 1. So num is equal to num plus 1. If this has been done completely, we can add it to the dictionary that we created up there, and let's say we call this investor partner name, and this will be equals to the list that we created, name list. And the next one will be what's going on here, and why is this going on like this? We have the investor, what else, partner spec web, investor partner, let's say spec web, their web page. So that will give us this, that will be assigned to this. Then the last one is investor partner email contact, investor partner contact. So this will be equals to this. So I think this should work for us. Then let's now create a data frame. Investor data frame will be equals to pd data frame, then our dictionary inside as an argument. So we want to return this investor data frame. We want to return the investor, return the data frame. Don't forget, we do not have the pandas import, so we want to import pandas as pd. So let's see if this works. If there is no error, we will want to get the data frame based on the data that we have extracted. So we have this investor data is equal to this. We have the URL, the base URL that we have here. Let's copy this, the base URL. So we start from page 1 of the base URL. Then we have the target. Let me look at the target class. This is the target class for us. So let's see, the target class and an empty list. Let's run and see if there is no problem. Wow, what's this? Investor description link not defined. So where is this from? This looks like a change of name in here. I am not that consistent with the naming. Let's see if it's not gonna break again. Let's check what we have. Name link not defined in where? Link, where is link? In get investor name. No, we changed something, so it's gonna be a bit okay. Soup web extract, we don't need this anymore. So 1 2 3 4 5, let's see. So in soup not defined, get email partners, get partners email. Let's look at our problem. In soup. So we have in soup blah blah. In soup here should be temp. Good. we'll need to do some sorts of that. I think we have been successful now. Yeah, good. So we can see in one scoop like this, we will be able to get the 117 data sets for each of the data sets that we have been exploring. So let's see. Good. Instead of having to do this for every time we want to extract the email, we run this down. We want to extract the name, we run this down. This has been done in one scoop. And if we investigate the investor data now, we have all this data in a data frame. Bravo. You can see we have the data: investor description, page link, investor partner name, investor partner web, investor partner email contact, and we've been able to extract it in one scoop. So this is more efficient for us now. I will leave this combined code in my GitHub link, and that link will be dropped under this video, so you can look up this combined code and understand. I will comment it and explain each of the functions and how they combine to work together for us. So this place is where we will end this episode. In the next episode, we'll still briefly explore this particular website, but I want to demonstrate how we can use GPT API endpoint to use the OpenAI model to extract data from the text on those investor partner web page. That will be something, I don't know if the data that will be extracted will be meaningful, but we'll look at this and explore this in the next episode. For now, we will stop here. We've done a lot in this episode. We can look up the codes and do some other exploration to learn more. So in the next episode, like I said, we will explore using OpenAI model to extract data from these web pages. And if you have found this tutorial meaningful or informative in any way, please don't forget to subscribe to our channel and like the videos and share with other people that might benefit from this tutorial. For now, let's keep on exploring. See you in the next episode.